Today, we are going to conduct an experiment on drop weight crusher. The aim of the experiment is to determine the crushing law constants using drop weight crusher. The apparatus required are drop weight crusher setup, sieve set, sample, and these are the equipment required. This is the drop weight crusher setup. This is the sectional view of that. We require a gyratory sieve shaker. We require a set of sieve shakers or mechanical sieve shaker, that is known as a row-tap sieve shaker, and a electronics balance to weigh the material retained on the screen. Theory: the crushing operation is carried out to effect the size reduction. During this size reduction, new surface area is created since a unit area of a solid has a definite amount of surface energy. The creation of new surface requires work to be done which applied by the release of energy when the particles break. The basic law of crushing and its energy is given as dE by dL is equal to minus CLP, where L is the size of the particle. The procedure: take a sample of particle size minus 8 plus 10 mesh, that is passing through 8 mesh and retaining on 10 mesh screen. About 50 grams of the sample is taken and is placed in a crushing zone of drop weight crusher. The bob, that is the weight, is dropped from a known height of about 1 meter for 50 times. The product is mixed using spatula after every drops for uniform mixing. After crushing, the product is screened and analysis is carried out. The average particle size is determined. The weight of the bob is noted, and also the height of fall of H. The bob is noted, and the calculations.
Today we will conduct an experiment on drop weight crusher. This experiment is done or carried out to calculate the constants, crushing law constants, that is Rettinger's law constant and Fick's law constant. Here we take a sample which actually passes through 8 mesh screen and retains on 10 mesh screen. We have to take the given sample and it is to be screened to pass through the 8 mesh screen and which retains on 10 mesh screen. That sample is taken in a sample holder. This is the sample holder, right? It is actually kept here, and the sample which is already prepared is actually poured into this. About 50 grams of the sample is actually poured into this, and this cover is closed, right, like this, and the weight is actually dropped over that so that the crushing will take place because of the impact. Like this, we have placed the weight here. The weight actually falls from a height of 1 meter, right? And by operating this lever, we can make the weight to fall like this, and we have to drop this weight for about 50 times. So every time, after 5 drops, we actually take a spatula and like this we have to drop the weight for 50 times, and after 5 drops we have to take out this and we have to actually mix the content well for uniform crushing, and then it is placed and this weight is dropped from the top of this for 50 times. After 50 times of dropping this, the sample which is actually ground there, that is taken out and the screen analysis is carried out. For this screen analysis, we have to take 8 mesh screen, then 14, 20, 28, 35, 48, 65, 100 and pan. This screen set is clean and arranged in this same manner, that is the increasing order of its mesh number. That is, at the bottom we have to place the pan, above that 150 mesh screen, above that 65, above that 48, then 35, 28, 14 and 8. In this order actually it is placed, and the sample which is actually ground after dropping 50 times of that weight is taken in this screen set, and it is screen and screen analysis is carried out. The sample is taken from this and it is poured over the top screen and the lid is covered, and then this is actually shaken manually or mechanically for a definite time for crushing, and whatever the material retained on each screen, we have to take it out, weigh and note down the weight. From this weight, we can calculate the weight fraction, and we can further do the calculation and find out the Kick's law constant and Rittinger's law constant.
Results: we have to calculate the Rittinger's law constant and Kick's law constant. Let us see the tabular column. This is the tabular column. Here mesh number, we have taken the mesh number 8, 10, 40, 28, 35, 48, 65 and a pan. The size of the aperture of screen that we have to note down from the standard list. And after conducting the screen analysis, we have to write down the material retained on each screen against their number, right? And all these weights are added, you get the total weight of the sample which is screened, and find the weight fraction of each. The weight of the material retained on the 8 mesh screen divided by total weight gives you the weight fraction. Then find the ratio of Wi by W, that is weight fraction divided by weight retained. Find Wi by dP, that is weight fraction by particle size, and then cumulative weight fraction. From this data, we can calculate the law constants. This is the observation and calculation. Weight of the sample taken, that is 50 grams. Mass of the bob or weight, that is M is equal to 1 kg. Height of the bob fall, H is equal to 1 meter. Number of bob fall, N is equal to 50. Acceleration due to gravity is 9.81. meter per second square. And we can calculate the energy of crushing. E is equal to mgHn divided by W, right? dP we can calculate 1 by Wi, sorry, 1 by sigma Wi by dP average. Then Kr, Rittinger's law constant, is equal to we have the equation E, that is energy divided by 1 by dP minus 1 by dP, where dP is the final particle size and dF is the feed size. And K, Rittinger's law constant, Kk is equal to E by log of ln dF by dP. By substituting the values of this, we can find we can find the constants. Thank you.